Welcome back to All This Math. This is Professor Parker, and I want to give a shout out to the people on this sweatshirt. I like to say it with my chest, if you're familiar with my channel. Winnie and Nelson Mandela, Osajifo Kwame Nkrumah, Patrice Lumumba, Thomas Sankara, Steve Biko, and Fela Kuti, right? Now, I do want to address something, because just in case you're wondering, because a lot of students wonder this, they wonder well, what do all these people had to do with math? Right? If they wasn't mathematicians, they wasn't like officially mathematicians or PhDs in math, why are they relevant to what we're doing, right? What we about to do, we're about to get into some dividing fractions, right? This is how they're relevant, just so you know. Math fundamentally is about problem solving. It's about developing your ability to solve problems. Not just problems in your math classroom, not just problems from your textbook, not just problems that your teacher writes on the board. It's about learning mentally how to approach a problem, recognize a problem, identify a problem, and then solve the problem, no matter what the problem is. It could be a problem in your community. It could be a problem in your household. It could be a political problem. It could be a cultural problem. It could be a social problem. Any type of problem. This is a transferable skill. Learning math helps you to solve problems. What these brothers and sisters got into, they were also problem solvers. They were revolutionaries. They were trying to solve problems in their community. So what should happen is you should be able to combine or merge your ability to solve problems that you help develop, that you develop from doing math and becoming excellent in math, with the history of what these brothers and sisters was doing, learning from, their writings, learning from their experiences, what they left behind, what other people have written about them in terms of their assessment. You should be able to learn from their successes. You should be able to learn from their failures, and then leverage their problem solving ability with your own, or merge it with your own problem solving ability, in order to then go out and make the world a better place for you and for your people. So in case you're wondering, what do these historical figures got to do with math? They got everything to do with math, because math is much deeper than just being able to answer a problem that your teacher writes on the board. Math is much deeper than that. Math is about developing your problem solving ability. So don't ever forget that. And in case anybody else is wondering, pass it on, let them know. Math is about problem solving ability. Revolutionaries were about solving problems in the community and in the world and in society. So what you're doing is you're developing yourself to be a person that can also work to solve problems. All right, now let's get into this. Dividing fractions. Now, this is a dividing fractions problem. I'm gonna do it two different ways, right? I'm gonna do it the traditional keep, change, flip way. And then I'm gonna do it another way, where we find common denominators and then we divide horizontally. All right, now, first of all, let's talk about what this means, because this is a sentence, right? This is basically a sentence. This equation is a sentence. 5/9 divided by 1/2. What does this mean? This means that we have some type of object that is divided up into 9 equal pieces. Our denominator is 9, so it's divided up into 9 equal pieces, and we are focused on 5 of them, right? And then we have another object that's divided into 2 equal pieces, and we're focused on 1 of them. Now, what we want to know is how many 1/2s can fit into 5/9. How many 1/2s can fit into 5/9? How many of those? So let's say we're talking about liquid, right? So let's say we have a container that is 5/9 of a gallon, right? And then we have a 1/2 of a gallon of liquid, right? We want to know how many of these, right, amounts of liquid, or we have liquid that's divided up into 1/2 gallon increments or parts, right? How many of these can fit into this? So the second number, which is also known as your divisor, how many of the divisor can fit into the first number, which is the dividend, whether it's a whole number or a fraction. In this case, we're dealing with fractions. So basically, simply put, how many 1/2s can fit into 5/9? That's what we're trying to figure out. How many 1/2s can fit into 5/9? That's what we're trying to get into. All right, so let's do this. Let's do the traditional method, which is keep, change, flip. Keep, change, flip. Keep, change, flip. Now, why is it called keep, change, flip? Because you go from left to right. You keep the first fraction the same. So you keep the first fraction the same. That's why we say keep. All right. So we write 5/9 because we keep that. We change the division sign to a multiplication sign. We change the division sign to a multiplication sign. Right. So that becomes you use a dot. You use an X if you want to. You use an asterisk. You use parentheses. Right. It's a lot of different symbols that we have to represent multiplication. So we kept 5/9 the same. We changed the division sign to a multiplication sign. And now we're about to flip the next fraction, the 1/2. Or technically speaking, we're taking the reciprocal of it. So that means the 2 goes upstairs and the 1 goes downstairs. 2 goes upstairs, 1 goes downstairs. So this becomes 2 over 1. Now we have a multiplication problem. So we got 5 ninths times 2 firsts, or 2 over 1. So now we multiply horizontally. 5 times 2 is 10. 9 times 1 is 9. 10 ninths. So that is an improper fraction. Why is it improper? Because the numerator is larger than the denominator, right? So that means that there are more parts than equal parts in the object. So the object is cut up into 9 equal parts, and we have 10 of them. How can that happen, right? That means the whole object is taken up, and we have 1 extra part left over. So that's why when we convert this to a mixed number, we have 1 and 1 ninth. Why? Because one group of 9 can fit into 10. That's where the 1 comes from. How much is left over? If those first 9 are gone, it's only 1 part left. 10 minus 9, the difference is 1. That's where this 1 comes from in your numerator. And why is there a 9 in the denominator? Because each part is a ninth. It's cut up into 9 equal parts. So 1 and 1 ninth. So what does this mean? This means that we can fit a whole 1/2 of the liquid in here and a portion of another 1/2 of the liquid. So we can fit a whole 1/2. That's where the 1 comes into play. Try to think about this. Try to visualize this. We can fit a whole one of these into this, and a piece of this also into that. So 1/9 is a piece, right? It's a piece of this. So a whole 1/2 and 1/9 of 1/2 can fit into 5 ninths. That's what that means. All right. So this is our final answer. I mean, you can say 10 ninths, leave it improper. You can change the 1 and 1 ninth, flip it, change it into a mixed number. But let me show you another way, right? Another way of doing this is, I'm going to rewrite the problem. And we can divide horizontally if we had common denominators. Now we got 9 and 2. Now a common denominator of 9 and 2 is 18. How do I get that? Just by multiplying 9 by 2. 9 times 2 is 18. So watch this. I got 18 divided by something else over 18. Something over 18 divided by something over 18. So look, if I double this 9 to get 18, I also had to double the 5. So an equivalent fraction to 5 ninths would be 10 eighteenths. An equivalent fraction to 1/2 would be 9 eighteenths, because 2 times 9 would give me this 18. So I also would have to multiply the 1 by 9 to get 9 eighteenths. So what I'm doing is I'm just trying to create equivalent fractions with different denominators, right? So 9 became an 18, so the 5 became a 10. The 2 became an 18, so the 1 became a 9. The 9 became an 18, so the 5 became a 10. The 2 became an 18, so the 1 became a 9. So now what we can do is we can divide straight across. So think about it. 18 divided by 18 is just 1. Because anytime you divide anything by itself, it's just 1. 10 divided by 9, let's just call that 10 ninths. And then 10 ninths divided by 1, see, now we have what's called a complex fraction. We have a fraction inside of a fraction. 10 ninths is inside of a larger fraction, right? So this is just going to become 10 ninths though. And isn't that what we got up here? And then that's still equal to 1 and 1 ninth. So that's another way. Like, I thought this was cool. I never learned this when I was in school, right? When I was younger, I never learned this. I learned this very recently, right? I learned keep, change, flip when I was in school, and that worked. But it's always important to know options and know multiple ways of solving problems. That's always very important. So make sure you know multiple ways of solving problems, and you can just solve problems in different ways, because, you know, you might be in the mood to just solve it differently. Or the way certain problems are set up, it might make more sense to solve it in a different way than what you're accustomed to, you know? So definitely practice keep, change, flip when you're dividing fractions. Practice finding common denominators and dividing horizontally also. Know how to do it both ways. And that'll help you just to be an all-around better math student and just a more mathematical oriented person just in the world. Because math is where it's at. Math is the thing that we really need in order to, as I said earlier, to solve our problems. All right? Because we're human beings, we're going to have problems. They're not going to go away if we try to ignore them. That's not how it works. You know, they're only going to compound and grow exponentially, and we need to learn how to solve them so that, you know, we can live better lives. All right? So go get some practice dividing fractions, and I'll holler at you on my next video. Peace.